The very smooth year-to-year shifts in the incidence of Kawasaki disease and exanthema subitum imply persistent infections of these diseases. The annual incidence of an infectious disease oscillates with a cycle longer than 1 year. This phenomenon is known as supra-annual periodicity. Anderson and May revealed that the cycle of the supra-annual periodicity, T years, is approximated as in the following equation 1. Equation 1. T is equal to 2 pi multiplied by the square root of d plus d prime multiplied by a, where d represents the latent period, d prime stands for the infectious period, and a denotes the mean age of patients. We used equation 1 to predict the characteristics of the etiological agent for Kawasaki disease. The monthly number of Kawasaki disease cases was obtained from Japan's nationwide surveillance of Kawasaki disease. The monthly number of pediatric infectious diseases reported from sentinel hospitals between 2000 and 2010 were obtained from the National Institute of Infectious Diseases. We applied wavelet analysis to these time series datasets to identify supra-annual periodicities. Figure 1 illustrates how the reported number of cases shift from year to year for Kawasaki disease and 7 pediatric infectious diseases. Of note, the annual number of cases of Kawasaki disease and exanthema subitum shift very smoothly from year to year. On the other hand, the numbers of other infectious diseases fluctuate. Wavelet analysis was applied to the time series data in Figure 1 to identify supra-annual periodicities in these diseases. The two blue lines indicate the 95% confidence limit. The area between these lines is reliable, and the colored area indicates the presence of supra-annual periodicity. For example, Group A Streptococcus has a supra-annual periodicity of 2.3 years. Remarkably, only in Kawasaki disease and exanthema subitum, supra-annual periodicity was not detected. This finding indicates that the supra-annual periodicities of these diseases were longer than 3 years. This is because 3 years is the upper limit of detection from this time series. We estimated the mean age of patients, A, of the pediatric infectious diseases based upon the surveillance in Japan. We obtained the latent period, D, and the infectious period, D prime, of the pediatric infectious diseases from literature. These values of A, D, and D prime were substituted into equation 1. As such, the supra-annual periodicities were predicted. This can be seen in the T predicted column of this table. As is shown in this table, the values of the T predicted were consistent with the supra-annual periodicity identified by wavelet analysis, that is T wavelet. Therefore, the data in this table validated the credibility of equation 1. We applied wavelet analysis to a time series dataset of Kawasaki disease cases, which was recorded between 1979 and 2010. This can be seen in Figure 3, where the number of cases increased smoothly and gradually after the 3 epidemics in 79, 82, and 86. During this stable period, the supra-annual periodicity was not identified. This represents that the supra-annual periodicity was longer than 10 years, which was the upper limit of detection from this time series. Meanwhile, the mean age of patients who have Kawasaki disease in Japan is known to be 2.4 years. These conditions, that T is longer than 10 years and that A is 2.4 years, were substituted into equation 1. As a result, D plus D prime was estimated to be larger than 1.1 years. Since the latent period, D, of Kawasaki disease is within 10 days, the infectious period, D prime, is longer than 1 year. Our analysis suggests that the etiological agent of Kawasaki disease infects the host persistently. We are grateful to Professor Yoshikazu Nakamura and Dr. Mayumi Yashiro of Juchi Medical University. Thank you very much.